welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about percent error. Let's get started. Let's jump right in with an example of percent of error. Let's read this one. Sam came back from his run, and his friend asked him how far he ran. Sam figured about 3.5 miles. Later, they drove the course and found out that it was actually 4.1 miles. How precise was his guess? How close is close enough? There is a way to figure out using math how good someone's guess, measure, or prediction is compared to the actual number, and it is by finding the relative error and the percent error of error. Let's take a little closer look at some definitions. So precision is how close the measurement is to the exact measure. Error is the difference between the exact value and the about measure. The relative error is the error over the exact value, and the percent of error is the relative error written as a percent. Now this might seem a little bit confusing, but when we work the problem out, it'll probably make a lot more sense. So going back, we need to find the percent of error. That's like finding the percent of change. We need to subtract and set up a proportion. So step one is to subtract. We need to find the error by subtracting the two measures, or the about measure, what he thought he ran, and the exact measure. So the exact amount he ran was 4.1 miles. About, or what he guessed he ran, was 3.5. So we take 4.1 minus 3.5. Now we have the error as 0.6. That's the difference. Step two is to set up a proportion to find the percent of error. The percent of error over 100 equals the error over the exact value. Now we want to consider what we do and don't know. That's our step three. Here's what we know. The error is 0.6. The exact value is 4.1. The percent of error is unknown. We don't know. So we'll use the variable, and we will let P equal the percent of error. All right, step four, put all the information into the proportion and solve. So we have P over 100, or the percent of error, P over 100, equals the error, 0.6, over the exact value, which is 4.1. Cross multiply, and we get 4.1P equals 60. 4.1P equals 60, we divide both sides by 4.1, and we get 4P equals 14.6341464, or we will call this 14 and 26 over 41. Now, because the decimal repeats, we can change it to a fraction to keep the answer exact. But Sam's approximation, for the most part, of how far he ran is over 14% off. Let's try another one. George measured the diagonal of a rectangle and found it to be 16 3/4 inches. The actual measurement of the diagonal, calculated using the Pythagorean theorem, found on the diagonal to be 17 inches. What is the percent error of George's measurement? Let's find out. First thing we're going to do is find the error by subtracting the actual and the measured lengths. 17 minus 16 3/4 equals 1/4. That's the error. We're going to list the parts of the proportion. The error is 1/4 inch. The actual measure is 17 inches. So the percent of error is not no. We're going to let the variable P equal the percent of error. Next, we're going to put all the information into the proportion and solve. So we have P over 100, or the percent of error over 100, and we have 1/4 over 17, or the error over the exact value. We're going to cross multiply, which gives us 17P equals 25. We're going to divide both sides by 17, and we get P equals 1.470588235, or 1 and 8 over 17. So George's percent of error is 1 8/17% off. All right, everyone, that just about does it for this lesson. Thanks so much for joining us, and we'll see you next time. Bye-bye.